Okay, here's our area of irregular figures video for today. Our learning target for today would be that you'll be able to apply formulas to the area of irregular figures. So we're going to take the formulas that we learned yesterday with triangles and parallelograms, and we are going to use them to find the area of irregular figures. And I'm going to give you different variations of how you might see irregular figures. Okay? If you need to pause, go ahead. At any time when I go on, if I'm going too fast, make sure you remember to pause or rewind. Otherwise, I'm going on to my next slide. First, what we're going to do is what we call decomposing irregular figures. And decomposing irregular figures, when we use that, is we are separating a figure into smaller parts. That is what decomposing is. It's breaking it into its different parts. So what we are going to do is to find the area of irregular figures, we are going to break the shapes. We're going to break the figure into shapes that we know the areas for. So we're going to break them into triangles and parallelograms. So in the bottom of the screen here, you can see that I have an irregular shape there. It's kind of made up of a couple of rectangles. Why would these be important? Well, in the other shape here, we're talking about painting a room maybe. If there's windows in there, we don't need to paint the windows. Hopefully you're not painting those. So you might want to find the area and take out the windows, because sometimes that can be a significant amount of area. So sometimes you have to find the area around those shapes. So we'll go over some examples of how to find different types of areas with different irregular figures. Okay, I'm going to move on to the next slide. In our first example, we're going to find the area. So again, we are going to write the formula, substitution step, and answer with label on every problem. Now the difference is in this problem, there's going to be multiple formulas, multiple substitution steps, and multiple answers until we get down to our final answer. So you need to make sure that you show and write that for every part that you decompose this to. Okay, so in example 1 here I have a trapezoid. Now there is a formula for a trapezoid, but we're not going to go over that. We're going to break it into smaller pieces. Now when you look at this, because I have the tick marks on the side there, that illustrates that they are congruent to each other, which means that the two sides of the shape, the left side and the right side, are congruent to each other, and that's going to be important when we move on here. So what I'm going to do is I'm going to decompose this into 3 shapes. I'm just going to follow this dotted line here. That's a good breaking point there, because that's a triangle. Then I'm going to do the exact same thing on the other side, and that's also a triangle. Now, if I would have done that better, because these are congruent, those 2 triangles are congruent. Now they don't look like it because of my pen stroke, but they are congruent. So that's going to be important when I'm trying to find the different dimensions of each one. Now I have 1, 2, 3 shapes. I have to find the area of each shape. So in my first area, that's a triangle. So that's going to be area equals 1/2 base times height. Write my formula every time. Now I'm going to substitute in my dimensions. Oh wait, I don't know my base. Can I figure it out? Yes, you can. If I know this is 15 here, that means this right here is also 15. Now the whole thing is 23. 23 minus 15 is 18. I'm sorry, is 8. Which means I have 8 left over. I have it broken into 2 equal pieces, so that's going to be 8 divided by 4, which is 8 divided by 2, which is 4. Okay, so that's going to be 4, and that's going to be 4. Now I know my dimensions of that triangle. It's going to be 1/2 times 9 times 4. When you do that, you get 18. Now I'm going to find the area of the second piece. So I'm done with this piece here. That's 18. Now I'm going to work on this rectangle in the middle. That's a rectangle, so that's area equals base times height. That is 15 and 9. Remember, it's 15 down here now. So that's 15 times 9. 15 times 9 is 135. Now I'm going to work with my triangle on the right side, over here. Okay, well that's the same as my other side, because that's also 4 and 9, so that's the same triangle as the other one. If you do have a shape that's broken into congruent pieces, you don't need to re-show your work. Okay, that's the same as number 1, so that's just 18. So now I have the area of each piece, 1, 2, 3 pieces. I broke it into 3 pieces. I'm going to add them together to put the piece back together. So add them, 18 plus 135 plus 18, and you get 171 feet squared. It's still area, so it's still squared units. So I find the area of each piece. Since I broke them apart, when I re-put them back together or add them back together, add my areas, and that gives me my final result. Okay, if you need to pause, go ahead. Otherwise, I'm going to move on to my next example. in my next example, I have a couple places I could break this shape into. I could break it up in here, but I'm going to break it up here. That's just where I decided I want to break it up. You could break it up into 3 pieces if you wanted. That's more work. I'm going to try to keep my pieces down. But I'm going to have 1 piece and 2 pieces. Okay, so I find the area of the first piece, which is this rectangle right here. It's a rectangle, so that's area equals base times height. That's my first piece. And that's 7 and 2. So that's area equals 7 times 2, which equals 14. Then I'm going to find, so I'm done with 1, I'm going to find the area of the second piece here. Well, I know this dimension is 3, but how tall is this? It is not 5. Okay, 5 is the whole thing. So how tall is just this part from here to here? Well, that's 2, and that has to be 3, because 3 plus 2 is 5. So that's 3 and 3. So this area of my second part, this area equals base times height, which is equal to 3 times 3, which is equal to 9. Again, I broke it into 2 pieces, so I add them together. So my overall area is 14 plus 9, which is 23. So I get 23 centimeters squared, and that is the area of those shapes. So when you're breaking these pieces up, you will have to do some additional math. Okay, to find this 3 again, I did 5 minus 2. That's where this 3 came from. So you always have to make sure that you're readjusting your measurements as you're working through these. Okay, if you need to pause, go ahead. Otherwise, I'm going to go on to example 3. In example 3, we need to find the area. Oops, I should have said area of the, just find the area. It's not a parallelogram. Okay, find the area. In example 3, I want to find the area of the shaded region. Okay, now this is harder. I could try to break these up into 1, 2, 3 triangles, which you can do. And I have enough information to figure that out. But that's a lot more work than what I'm going to show you here. Sometimes you can work by thinking of, well, I got a triangle here, and I've cut out a square there. So what would we do for that? Well, what I'm going to do is first find the area of the big overall triangle. Okay, I'm going to find the area of that. So that is my first shape. So that's going to be area equals base times height. And the base of that is 10. Oops, I'm sorry, area equals 1/2 base times height, because that's a triangle. So that's going to be 1/2 times 10 times, and then the height here is 15. So 1/2 times 10 times 15. That is going to equal 75. Alright, now I'm going to find the area of my second piece here, which is the square. That is going to be area equals base times height. So that's going to equal 5 times 5, which is 25. Now in all the other examples, I've been adding them together, but this shape is not made up of a triangle plus a square. This shape is made up of a triangle with a square taken out or subtracted from it. So what I'm going to do with the 75 and the 25 in this one is do 75 minus 25, and that is going to give me 50. So my answer to this one is 50 meters squared. So sometimes instead of breaking it up into pieces where you're adding, you can actually break it up into pieces where you're finding the area of something larger and then subtracting the pieces that are missing from that larger shape. Okay? If you need to pause, go ahead and pause. Otherwise, we'll be moving on to our next slide. Alright, we're going to try this one on your own. We're going to find the area of the shaded region. So find the area of this region in here. Go ahead and pause your video and work on it. And when you're done, hit play. Okay, hopefully you paused it and actually worked on it first. I'm going to work on, find the area of the larger rectangle, and then subtract the part that I'm missing. So the first thing I'm going to do is find the area of this larger rectangle. That is area equals base times height. It's 11 and 8. So that means me 11 times 8, which is 88. Now the second shape I'm going to work on is this white part in the middle. That is also area equals base times height, and the dimensions of that are 9 and 6. So it's going to be 9 times 6, which is 54. Now, again, the larger rectangle is missing this part. It's kind of like a pool, right? If I was tiling around a pool, if this was a diving board, and I had my pool over here. Okay, so that is going to be, how much do I tile? This is what you would use to figure that out. So I'm going to take the 88 and I'm going to subtract 54, the part that I'm not tiling around or trying to find the area of, and that is going to give me an answer of 34 inches squared. So that is my final answer there, 34 inches squared. Okay, if you need to pause to finish writing that down, go ahead. Otherwise, I'll be going on to my last screen. Guys, I just want to remind you, don't forget to write your summary, and have a great night, and we'll work on these tomorrow.